It began with a dream of reaching out, of touching the cosmos. On September 5, 1977, Voyager 1 launched from Cape Canaveral, Florida, carrying our hopes and questions. Its mission: explore the giant planets, then journey onward, forever. Today it's the farthest object we've ever sent from home, a tiny speck in the interstellar void. As of June 30, 2025, Voyager 1 is over 16 billion miles away, 173 times the Earth-Sun distance. Light takes more than a day to reach it, a command and reply takes 2. This 1970s spacecraft is our silent scout, reporting from a realm we can only dream of. Attached to its side is a message, the Golden Record, a time capsule from Earth. It contains greetings in 55 languages, a baby's cry, whale song, and music from Bach to Chuck Berry. It's a bottle cast into the cosmic ocean, a gesture of hope that someone, someday, might find it. The odds of discovery are infinitesimal, but that wasn't the point. The real audience was us. It forced us to define our own legacy. What do we want to say about humanity? What music, what images, what sounds represent the best of us? In sending a message to the stars, we ended up speaking to ourselves. We distilled our existence into a single, coherent message. Voyager's journey is a profound statement of our reach and curiosity, just in case we defined who we are. Before venturing into the unknown, Voyager 1's first stop was Jupiter, the king of our solar system. In 1979 it revealed Jupiter as a world of violence and beauty, swirling clouds, lightning larger than continents, storms that could swallow Earth. The Great Red Spot became a furious, centuries-old storm. Voyager's images transformed Jupiter from a distant point of light into a dynamic, living world. Its instruments measured a magnetic field so vast it would dwarf the full moon in our sky. But the real shock came from Jupiter's moons. Voyager gave us our first close-up of Io, a volcanic wonderland, spewing plumes hundreds of miles high. It was the first time we'd seen active volcanism beyond Earth. This discovery reshaped our understanding of planetary systems. Tidal heating from Jupiter's gravity made Io the most geologically active body in the solar system. It opened the possibility that other moons, even far from the sun, could harbor hidden energy, and maybe water. The encounter with Jupiter rewrote the textbooks. After Jupiter, Voyager 1 set its sights on Saturn, the solar system's jewel. In November 1980 it arrived and revealed Saturn's rings as thousands of icy ringlets, not just a few bands. The rings were dynamic, with spokesbraids and tiny shepherd moons corralling particles. Saturn's rings became a cosmic dance of gravity and ice, a scientific puzzle. Voyager's close flyby of Titan, Saturn's largest moon, revealed a thick, nitrogen-rich atmosphere denser than Earth's. Titan was a world frozen in time, reminiscent of primordial Earth. But this flyby flung Voyager out of the planetary plane, ending its grand tour. It couldn't visit Uranus or Neptune that was left to Voyager 2. Voyager 1's primary mission was over. Now, it was set on a new path out of the solar system toward the stars. Its endless journey into the interstellar dark was about to begin. For decades after Saturn, Voyager 1 sailed onward, its mission transformed. It became a scout, heading for the heliopause, the boundary where the sun's influence ends and interstellar space begins. The heliosphere, a magnetic bubble carved by the solar wind, is our cosmic harbor. As Voyager traveled farther, it detected the solar wind slowing and cosmic rays increasing, signs it was nearing the frontier. In August 2012, Voyager's instruments registered a dramatic change. Solar particles dropped, galactic cosmic rays surged. Voyager 1 had crossed the heliopause, humanity's first object in interstellar space. Now it sampled the interstellar medium, directly revealing denser plasma and complex magnetic interactions. Voyager was no longer just looking at our solar system, it was measuring our galactic neighborhood. It became a lonely outpost, billions of miles from home, telling us what the universe is like out there. This was a monumental achievement for science and engineering. We were finally tasting the stuff between the stars. Voyager's data redefined our understanding of the sun's reach. It was a silent witness in the great dark expanse. Communicating with Voyager 1 is one of humanity's greatest technological feats. Its transmitter is as weak as a refrigerator light bulb, 23 watts. By the time its signal reaches Earth, it's a whisper measured in quintillionths of a watt. The Deep Space Network, giant radio antennas in California, Spain, and Australia, strains to catch Voyager's call. As Earth rotates, these stations hand off the signal, ensuring we never lose contact for long. The round-trip communication time is over 45 hours. Every command takes 2 days for a reply. Troubleshooting is painstaking. Every move must be triple-checked. Voyager's computers have less memory than a car key fob. Its data is recorded on an 8-track tape. A new generation of engineers has become caretakers, learning to operate this vintage hardware. They keep Voyager alive with ingenuity and historical detective work. It's a global effort to hear a faint voice from the cosmos. As Voyager 1 ages, its systems grow fragile. In May 2022, it began sending garbled data from its attitude control system, though it was still pointed at Earth. Engineers traced the problem to data being routed through a defunct computer. A clever command rerouted the data, fixing the issue, a warning that the hardware was failing in unpredictable ways. Then, in November 2023, Voyager 1 went silent. Not its signal, but its data. For 5 months the team worked blind, sending commands and waiting for a response that told them nothing. The silence was a stark reminder of the mission's fragility. Finally, a memory readout revealed a clue. A single faulty memory chip in the flight data system. It was like finding a word in a sea of static. The team had a diagnosis, but the solution would be even harder. Each new anomaly felt more threatening than the last. Voyager's age was catching up with it. The faulty chip held crucial software code. Without it, Voyager couldn't send data home. Engineers couldn't replace the chip, so they devised a workaround, slicing up the code and storing it in different memory locations. It was like rewriting a book on sticky notes scattered through a library. Each section had to be placed and stitched together perfectly. On April 20th, 2024, the first patch was sent. Then came the agonizing 2-day wait. The signal returned. Voyager was talking again. Engineering data flowed and relief swept the control room. Over the next weeks, more commands restored science data. By late May, Voyager was once again reporting from interstellar space. This recovery was a triumph of persistence and creativity. Engineers old and new collaborated, refusing to give up. Their ingenuity gave Voyager a new lease on life. Across billions of miles, they resurrected their distant explorer. Despite heroic efforts, Voyager 1's power is fading. Its 3 nuclear batteries, RTGs, lose about 4 watts each year. Engineers have shut down non-essential systems, turning off heaters and putting instruments on standby. Every watt is precious. It's a delicate balancing act to keep the transmitter and key instruments running. They've even repurposed old circuits to eke out extra power. Soon, there won't be enough power for even a single instrument. Eventually, the transmitter will go silent. The deep space network will listen, but there will be no reply. That will be the end of Voyager's mission. But not its journey. It will sail onward. A silent ghost ship through the Milky Way for millions of years. Its story will outlast us all. Voyager's final days are a testament to human ingenuity and care. Voyager 1 is more than circuits and wires, it's a symbol of the best of humanity. Conceived by one generation, launched by another, and managed by a third, it has inspired countless dreamers. Its story connects us to the cosmos in a personal way. The golden record is a reflection of our aspirations, a statement that we are capable of beauty and wonder. When we look up, we know a piece of us is out there, a lonely ambassador in the vastness. Voyager's journey is a human mission, reminding us what we can achieve together. It elevates our perspective, pulling our gaze to the stars. It is a testament to daring, curiosity, and hope. When Voyager 1 goes silent, its legacy will endure. Its data has changed our view of the solar system and given us our first taste of interstellar space. Its discoveries at Jupiter and Saturn alone would have made it legendary. But its true legacy is the journey itself, a testament to our drive to explore. Voyager 1 reminds us that exploration is in our DNA. It challenges future generations to dream bigger and reach farther. Long after we're gone, Voyager will carry our music, greetings, and story through the galaxy. It is our legacy written on the canvas of space-time, a whisper of hope, a declaration that we once reached for the stars, and did.